Hi, I'm Timothy Priscilla with my Math 1324 class. Today we're going to use Gauss Jordan elimination to solve a linear system of equations. I just like that name, Gauss Jordan. It sounds so, reminds me of that French actor Louis Jordan from Octopussy. I think it was the bad guy in the James Bond movie Octopussy. So anyway, the first thing we do, notice that the like variables are aligned. We have the constant term on the right hand side. So we're going to create our matrix. I draw my brackets. Each equation is going to get a row. There are 3 equations, so there's going to be 3 rows. The coefficients for x are 4, 3, negative 2. The coefficients for y are negative 8, 3, and 6. The coefficients for z, 16, 39, negative 1. I draw a vertical bar to indicate that I'm moving to the other side of the equal sign. And then I have my column of constants, 24, 18, and negative 10. In order to get this in reduced row echelon form, the first number in row 1 that's not a 0 needs to be a 1. So I'm going to use that first elementary row operation. Multiply or divide all the numbers in a row by a non-zero constant. In this case, I'm going to divide. If I'm trying to change an integer to a 1, I just divide through by that number. Dividing by 4 is the same thing as multiplying by 1/4. So I'll say row 1 divided by 4 gives me a new row 1. So there's going to be a lot of recopying here, and you'll have to be careful. Don't miscopy something when you're just carrying values down. Notice rows 2 and 3 are not changing. I can go ahead and write those down. Now, row 1's changing in this cycle. Divide by 4. 4 divided by 4 is 1. Negative 8 divided by 4 is negative 2. 16 divided by 4 is 4. 24 divided by 4 is a positive 6. So we now have a leading 1. We got our leading 1. Here it is. There's the leading 1. In order to be in reduced row echelon form, remember that all numbers in the same column as a leading 1 must be 0. So we're going to use the second row operation. Add a multiple of a row containing a leading 1 to another row to yield a new row. And that's what we'll be using. That's the operation that we use most frequently because that's what we use to get zeros. And when we get this in reduced row echelon form, the most common number should be a 0. So you ask yourself, you have a 1. What would that number need to be so when you added it to 3, you'd get a 0?
1/3.
No, 1/3 plus 3 wouldn't give me 0. Negative 3. So you just change the sign on that number you want to change. So negative 3 times row 1 plus row 2 gives me a new row 2. What would this 1 need to be? So when you add it to negative 2, you get a 0. A 2, so you go 2 times row 1 plus row 3 gives me a new row 3. We're adding a multiple of the row containing the leading 1 to the new row, to a row to give us a new row. And to decide, how do you decide what you multiply by? The number you want to change to 0, you change the sign on it. So row 1 is being recopied now. We're not going to change row 1. Row 1 is going to stay 1, negative 2, 4, and 6. And here we go. Multiply by negative 3 and add it. 1 times negative 3 is negative 3 plus 3. That gives me a 0. Hey, Orlinda, I'm doing a problem from my math lab with the Gauss Jordan elimination. Yeah, and I'm recording it too. Okay, so.
I'll try checking in with you later.
Okay, I'm through here at 10:50. So okay, bye bye. That's the Pearson representative. Okay, or Linda. I can't remember her last name. I only remember her first name. Linda. Okay. Well, this I'm not going to upload this tape. This recording. I'll tell you that much. Multiply by -3. That gives us a +6. Add it to 3 to give me a 9. Multiply by -3. What's that going to give us? -12 plus 39 gives us a 27. Multiply by -3. Add it. What's that going to give us? That the -18 plus 18. I agree with 0. Now do the second. You see why I say these are the steps that are going to take the most time. Now multiply row 1 by 2 and add it to row 3. Multiply by 2 and add it. That gives us a. Now to become a +2 plus -2, which is 0. Multiply by 2. That becomes a -4 plus 6 gives us a +2. Multiply by 2. Y'all tell me. That gives me 8. Plus a -1 gives me 7. Multiply by 2, 12. Add it to -10. That gives me a 2. I should have worked this problem out beforehand to see. I didn't think it was going to be that messy. Well, the final answer isn't that messy, but I think that the work we're about to get into is going to get messy. Well, maybe not. We got a leading 1 in row 1. We zeroed out the column. Now you go to row 2. The first number that's not a 0 needs to be a 1. So what number am I going to change to a 1? I need a leading 1 on row 2. I'm going to change that 9 to a 1. To get a leading 1, remember that's when you multiply or divide. So I'll divide that 9 by 9 to give me a 1. So I'll say row 2 divided by 9 gives me a new row 2. Row 1 is going to stay the same. Row 3 is going to stay the same. The only thing that's going to change in this cycle, that's a +1. That's a +1 and -2. Okay. You see what I mean when I say you're going to be doing a lot of recopying? You have to be watching and making sure you don't miscopy something, because if you miscopy something, there's one little sign, drop it, then that'll throw everything else off. So divide by 9 here, 0. 9 divided by 9, 1. That's why we did this. 27 divided by 9, 0 divided by 9, 0. We now have our leading 1. There's our leading 1. We have to use that 1 to zero out the column. The one time I forget to turn that on or to leave it in the office. The one time. Okay. Okay, I got my leading 1. I got my leading 1. I should just hit stop here. But anyway, so I have my leading 1. What do I need these other numbers to be? 0. I have to use the leading 1 to get the zeros. So let's get rid of that number there first. What does this 1 need to be so when I add it, that -2 becomes a 0? 2, so you go 2 times the row containing the leading 1. That's row 2 plus row 1 gives me a new row 1. Here, you tell me the operation. What operation will I use to change this +2 to a 0? So I'll go -2 times row 2 plus row 3 will give me a new row 3. So In this case, in this cycle, row 2 is not changing. It's going to stay a 0, 1, 3, and a 0. Row 2, you take it, multiply every number there by 2, add it to row 1. Multiply by 2 and add it. What does that give us here? 1. That's a 0 plus 1 is 1. Multiply by 2 and add it. That'll give me a 0. Multiply by 2 and add it. That'll become a 6 plus 4. I agree with 10. Multiply by 2 and add it. That's going to stay a 6. Now multiply row 2 by negative 2 and add it to row 3. Multiply by negative 2 and add it. Negative 2 times 0 is 0 plus 0. That stays a 0. Multiply by negative 2 and add it. Now another 0. That's why we're doing this, to get a 0 right there. Multiply by negative 2, that gives me a negative 6. Add it to 7, that gives me a 1. Multiply by negative 2 and add it. That gives me a 2. Notice something. If you do the pattern that I'm doing, get the leading 1, 0 out the column. Move to the next row. Get the leading 1, 0 out the column. Notice once I got that leading 1 in column 1 and zeroed out the column, has any of that changed? No. You've got to get the leading ones from left to right the way I'm doing it, or else you'll wind up getting a 0 in one spot, and then 5 minutes later you change the 0 to a negative 7. So unless you want to undo the work that you've already done, you have to follow the pattern that I'm using. We got a leading 1 in row 1, zeroed out the column. We got a leading 1 in row 2, zeroed out the column. We're ready to go down to row 3 and get a leading 1, and we finally get a break here. The first number that's not a 0, what is it? It's already a 1. We don't have to change the number. We already have a 1 there. So what do we do next? We have to zero out the column. Okay, I want to change that positive 10 to a 0. I'm using row 3. You tell me the operation I'm going to write there to change that positive 10 to a 0. What am I going to? Negative 10. You want to, what number do you add to 10 to give you a 0? A negative 10. So negative 10 times row 3 plus row 1 gives me a new row 1. What number do you want this to be? So when you add it here, you get a 0. Negative 3, so call out the operation we're going to use to change that 3 to a 0. Negative 3 times row 3 plus row 2. So there's not another row to go down to get a leading 1, so after this we should be finished. Row 3 is just being recopied. Here we go. Multiply by negative 10 and add it. 1. Multiply by negative 10 and add it. 0. Multiply by negative 10 and add it. I think we're going to get another 0. Multiply by negative 10. That gives us a negative 20. Add it to give me, I agree, negative 14. Now go through multiplying row 3 by negative 3. Multiply by negative 3 and add it. Okay, we got another 0. Notice we haven't changed that row, that first column that we'd already fixed. Multiply by negative 3 and add it. That stays a 1. We didn't change the second column. We're not undoing the work that we'd already done. Multiply by negative 3 and add it. Okay, multiply by negative 3 and add it. A negative 6. Is this in reduced echelon form? Yes, let's verify that. Here are the conditions for reduced echelon form. Where are they? There. The first non-zero number in each row is a 1. Yeah, that's satisfied. Any numbers in the same column as the leading one must be 0. Is that satisfied? Yes. Each leading one's to the right of the leading one in the previous row. In other words, the leading ones are falling from left to right. Yes. We don't have a row containing all zeros, so that's satisfied arbitrarily. Yes, this is in reduced row echelon form. Let's convert this back to a system of equations. Let's convert it back to get our final answer. Remember, the first column was the coefficients for x, the second column the coefficients for y, the third column the coefficients for z. That first row says 1x plus 0y plus 0z is equal to negative 14. In other words, 1x equals negative 14. What does the second row say? 1y is equal to negative 6. The third row, 1z is equal to 2. And actually, this is nicer than the other one that I did this morning. The other one I did this morning had some messy fractions popping up. Realize, suppose that had been a 29 instead of a 27, this number here. 9 divided by 29, you'd wind up with 29 ninths. And so you could wind up with some messy fractions along the way. So, any questions?